Hello YouTube learners and students. This is Dr. Satish Singhal PhD. Okay, I have the wrong screen. I wanted actually this one. So this is my C++ arrays video number 2. I'm going to talk about sequential write and read access to array elements, and I'm also going to talk about physical and logical length. This may not be a large video, but maybe it is. But we're just confining ourselves to a couple of key concepts here. So, array's physical length versus logical length. Physical length is array's capacity, which is decided by the number inside the declaration bracket. Array capacity of BP array below, this should be below, sorry. Below will be 15. So if I declare something like this, capacity will be 15. Static arrays are often declared larger than the usage requirement. So I might be only storing maybe 10 or 11. Imagine that we only fill array members from index 0 to 9 in this one contiguously, then the filled capacity is called logical length. And now we're going to show another piece of code and picture in the next slide to show you what is the meaning of physical length and logical length. And if all members of array are populated by the user, then of course physical and logical lengths are same. Physical length could be larger than logical length, but logical length can be at maximum equal to physical length. So here's our code. I have prime numbers here. So I declare an array called int primes, capacity for 10, but then I'm putting only 1, 2, 3, 4, 5, 6, 7 prime numbers in there. These are all prime numbers. So my array is going to look like this. Prime 0 contains 1, primes 1 contains 2, primes 2 contains 3, primes 3 contains 5, primes 4 contains 7, and primes 5 contains 11, and prime 6 contains 13. So in this case, physical length is 10. So this whole bracket shows me the physical length, but I filled only 7. 1, 2, 3, 4, 5, 6, 7. So this will be my logical length. Now, this is the importance of the logical length. Arrays in C++, you can declare their capacity global constant. So in a way, you do know the capacity. All the arrays themselves don't remember it. There's no function inside the array that can tell you it's either physical or logical length. And logical length is the length that has the user data. So sometimes we need to know that length. So in C++, arrays don't remember their length. You have to find a mechanism to know that. That was done to increase the speed, by the way. Everything in C++ or C is designed to increase the speed. So in order to make it faster, they decide not to have array carry their length, either physical or logical. But physical declared globally, so it's not a problem. Okay, so now we want to learn about write and read access to array members. Remember, the arrays are homogeneous in the sense that members are all same data type. And data type decided at the time of declaration. If you go to previous slide, this declares the data type of primes array, and all these will be same data type, homogeneous. Though array members can be populated randomly or sequentially, in this video we'll discuss sequential access only. So we use the for loop for sequential access, although you can use any looping structure for sequential access to array members, but for loop, being a count control loop, is most convenient. Imagine that we wish to populate an array with number table of number 2, so like 2, 4, 6, 8, 10. Then code for that we're going to show in our compiler Xcode. And in this code we show the write access, and after that we show the read access. So I'm done with my video PowerPoint here. Let's go to our source code. So this is my source code to populate an array with number table of 2, and this is how I do it. So my number table is going to go from 2 to 20. So I need array element 10 array element. Now I'm going to populate it with number table for 2, and both of them I declare as global constants, which is a good way to do it because constants cannot change. So when I do this declaration, int number table max curly braces, then an array of integer type of value member number 10 is created, and 0 is filled in all of them at that time. This means 0 is filled. So what is my mechanism for sequential access to write to all their elements? I'll run a for loop from index 0 to index less than max. So 0 to 9, index will be 0 to 9, and that's index plus plus. That means I'm increasing index one at a time. And then I'm filling into the array called number table number into index plus 1. So let's see how it's going to populate. First time index is 0. So in the first element, number table 0, I'm going to put 2 into index of 0 plus 1. So I'm going to put 2 the first time. And then I increase the index by 1. 1 less than 10 max is true. So number table index 1 will have 2 into, remember index was 1 now, 2 into 2, so that will be 4. Then it becomes 3. 3 less than 10 is true. Number table square bracket 3 would be 2 into 2 plus 1, sorry, 3 plus 1 is 4, so that will be 2 into 4, that will be 8. So we just keep going like this. It will be 2, 4, 6, 8, 10, and so on until 20. And then this line here, this loop here fills the array. And then we do something called sequential read access. So we just use the same for loop, index 0 to index less than max, index plus plus, and we use cout. That means we are printing every array element that was filled here. Okay, so this is the write access, this is the read access, sequential. Okay, so let's see how this program works. This should fill up with number table for 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And they should print those numbers. Okay, so that's the sequential write access, and this is the sequential read access. So we'll just run this program and see how that works. And actually I ran it before, so we see that, and run it again, and that's what we get: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's the procedure for sequential access for writing to the array element or reading the array elements that were populated by this loop. Okay, so in this video we'll just limit ourselves only to that much. Next video we are going to do will be passing array to functions for the purpose of populating them and also for the purpose of printing them. First, we'll show you the filling the array from the keyboard and print it to console. And then maybe we'll do one example of reading the array from a file and outputting to another file. And after that, we'll do our design example. We'll do some more things about arrays and design example 7. Okay, so I'm just going to stop here. This is Dr. Satish Singhal, PhD, Professor of Computer Science, El Camino College, Torrance. And soon I will see you in the next video. Thank you. And